thought I'd take a little bit closer look at the actual lights themselves, maybe take them apart. But first I thought I'd look at the box here. Like car accessories. One word, car accessories. These come in, according to this, a variety of colors. I assume these are per pair, so like 2 red, 2 blue. The ones available at Banggood are all red, all blue, and all white. Not amber, surprisingly. I would think that would be the most popular for legitimate use of these. You know, for snow plows and tow trucks and construction vehicles and that kind of thing. I think it'd be a lot more call for amber if you're using them legitimately than red or blue. Blue, it's possible you could use it legitimately. There's some places where firefighters use blue instead of red, which has always been odd to me, but I guess that's possible. And white you could also use as an alternative to amber for construction and so on. But still, and you know, use common sense. Don't put these in your vehicle if you're not authorized to use them. You know, we don't need that. I also want to say, you know, even if you do have a legitimate use for these, still don't put these in your vehicle. Get something better. Now, for volunteer firefighters, for example, I believe the cost to outfit one firefighter is something along the order of $7,500. It's thousands and thousands of dollars anyway. You know, just for the clothing alone, protective clothing, you're talking, I think, around $2,500 and probably around $5,000 for the breathing apparatus. So it's a big investment and reasonably so for, you know, it's worth it for safety. But something to bear in mind, and I believe this is true, that for both police and firefighters, the number of deaths in both of those professions, it's roughly 50-50 between things you're actually doing on the job or car accidents, you know, automotive accidents, getting to the scene or returning from the scene. That's why emergency lighting on vehicles is such a big deal. You know, if you're a police officer, you're roughly, and it changes year to year, it goes back and forth, but you know, you're roughly as likely to be killed doing something, you know, in a shootout or whatever it is, you know, things you think of as police activity. You're equally as likely to be killed just driving around in your patrol car, and similarly responding to fires for firefighters. I believe this is true. So if you're going to invest, you know, $7,500, or somebody's going to invest $7,500 in you in protective equipment as a volunteer firefighter to cover your 50% where you're doing the firefighting, you might want to invest more than $15.57, which is actually what I paid for this. I said earlier between $20 and $25, but it was actually $15.57 American, including shipping with insurance. You know, invest more than that in your safety to and from the fire. So, also I like here in this vehicle, this box rather, is N8 Police, and it's got what look like square rather than rectangular lights, sort of like they're sitting on top of the vehicle. Yeah, that looks legit. Anyway, it also says here that they're between 4 and 6 watts, so we can measure that and find out. Let's try that. So now, unfortunately, I'll get my multimeter in. Unfortunately, the nice clip-on leads and stuff are all in storage still, so we're gonna have to be a little creative here. Because I don't have enough hands for all of this. I wonder if we can do this. I'm gonna wrap this around. Will that stay? And let's see. Now, if it's 4 to 6 watts, let's say it's 6 watts at 12 volts. That's half an amp, right? So let's see. Well, can we see this here? Move this over to this setting. Hold on. Milliamp should be appropriate. Let's see if we can manage this. All right. So we've got a black wire here. Yeah, this is sketchy. This is not the way to do things, really, but we'll just have to make do. Yeah, it's only 12 volts, so I'm going to take this lead off here. How about that? Oops, backwards. chance here. Might as well get it right. So just idle. Can you see that? 27 milliamps idle. This is with the box on, but not actually doing anything. Yep, goes to 0 when it's off. That's fairly high for being off. All right, so let's turn them on here. Well, it's changing too rapidly here. Yeah, the meter can't really keep up. It seems to do best in this mode here. Yeah, so peak I saw it go to 400, so it could be 500 milliamps. That would be kind of within the range. All right, so 5 watts total, or 6 watts total between these 4 lights. 1.5 watts each. They're not going to be super bright. So, all right, let's turn this off and follow good practice and put it back in voltage. All right, so let's get this battery out of the way. I want to take one of these apart. Let's see what's going on inside. I'm assuming these are a serial parallel kind of organization. I don't know if these are just going to be the standard type, traditional LEDs, or going to be something fancier. So let's take this apart. Oh, and look, if you look here, you see the wire is just going through a hole here. There's no grommet or anything. So again, this is not going to be super reliable. It's not so waterproof. I don't know if these have a great legitimate use, but they work for me. So, and gee, $15 shipped. Can't really complain. For my purposes, at that price, it's not bad at all. So I'll take off these little bracket things here. So I'm thinking maybe these are just going to be the 5mm type, extremely normal LEDs in some kind of serial parallel arrangement. What do we have actually for, how many are there? So we've got 9 is 18, and 4, so 22. That doesn't divide up super easily. Let's see if we can get this apart here. Don't really have a good, there we go. Thing to pry it apart with. Oh yeah, just normal LEDs with resistors 1, 2, 3, 4, 5, 6, 7, 8. Interesting. I assume there's one per one per series run, is that right? So, so here's your positive rail across the bottom, your negative rail across here, and that's kind of an odd arrangement. I might have to draw this out. One moment. Okay, so what's going on here is, I realize that these are, you look at the color bands, these are different value resistors. So what's going on is that they're running 2 in series, 2 in series, 2 in series, and then sets of 3 in series. And they're just using a higher value resistor for the set of 2. So, not a whole lot to look at there. And I'll put this back together. I'm going to set this aside, do that off camera since it's not terribly exciting to reassemble things. Now let's take the control box apart and see what's inside there. Alright, so this, see one screw there. Oh, here we go. Yep, the sound of quality. So we want to open this up anyway and get that out in case it's a solder ball or something that might short it out and damage it. Is that all it takes to get it apart? Does this clip together and what does this do? My spudgers are upstairs. Let's see what we can do though. Don't want to break it. Does it feel like there's a screw underneath this maybe? The sticker? Doesn't really seem like it. So what's going on? Let me get my spudger and do this right. Alright, now with the spudger in hand, let's see if we can make any progress here. The one's a bit sturdier. Let's see, there's like a little, I guess it's meant to be a PCB support. I thought perhaps it was a clip, but I don't know. Seems like it's at this corner. Perhaps there's something under that sticker. Don't want to run the screw. No, it doesn't look like there's a screw or anything. What is going on? Alright. I may have to stop recording while I mess with this. One moment. Aha! Well, foolishly, man, there's one screw here. It didn't occur to me that it would be under this sticker, which of course it would be. So let's get rid of this. The quality assurance sticker. Of course it would be exactly opposite that one. Alright. Not like we're going to have warranty service on this anyway, so I don't care about pulling that out. Okay. Interesting how that this LED doesn't really line up. Oops, I think I just busted it. This is not going so well. Oh, good. Still works. Maybe it lines up a little bit better with that light now. Let's see. Alright. Yep. So the LED just shines through that sticker. And here we have the board. Just feed it out. So, switch. Oh, there's actually well, let's find out what that thing rattling around was. Oh, it was a piece of plastic that apparently broke off. I guess just a mold sprue or something. It's very kind of thin. Doesn't feel like it actually broke off anything. But at least it wouldn't have shorted anything out. So we've got a diode here, looks like. One of these 8-pin dips, probably a microcontroller. I don't really see any marking on that. Let me check that out. Get the magnifying glass here. More for the light than the magnification. No, it doesn't say anything on it. It was anonymous, probably a PIC clone. Some capacitors and I guess these are probably transistors to drive. These always go in pairs, so one for each pair. They can be driven independently. So, yep, about what you'd expect. Let's see if it slides back into these little board holders in here. Let's see, pull that through. Okay. Oh, I didn't get that in right. So nothing very exciting in inside, but about what you'd expect. Also, I should point out that there's this reflector and everything on these lights. There's no waterproofing at all. There's the back part of it here. I mean, there's just the hole through the back. There's no gasket or anything. So again, not really suitable for use on the outside of a vehicle anyway, but perfect for me. I think I will actually probably try to seal this a little bit with some silicone, just in case it does happen to rain or snow even during Halloween. That's not unheard of. In fact, it's only a few weeks later, and we're expecting our first snow possibly tonight, maybe just a little bit of a dusting. So, there you go. A little bit more in-depth look at these Chinese LED strobes. Okay, to make up for putting you through the idiocy of me trying to open the controller box in every way but the obvious one, I thought I'd go to the trouble to diagram this board. So, here's what I've got. It comes in through the power switch, goes through a diode, and this is nice. So this is to prevent or protect against reverse polarity. So if you connect the whole thing backwards, you're protected from that, which is nice of them to do. I wouldn't necessarily expect that on something this cheap. And then there's a capacitor across the entire supply for filtering. There's the power LED, 1K resistor power LED. And then off the positive rail goes the connections to the 4 LED modules, the positive side of that. 4 of those. Then we've got the sort of the power supply circuit here. There is a very simple way of doing this, cheapo way. So there's a 390 ohm resistor to limit the current, a capacitor, and then a Zener to set the voltage to 5 volts. All right, and that connects to these 2 pins. We don't know what this chip is, but it's compatible with the apparent pin out of a PIC 12. It's likely what it is, something like that, or a knockoff. These 3 pins are the A, B, and C buttons connected through switches to ground. And then these 2 outputs are the pairs of LEDs, the ground switches for the LED modules. So those go through a 1K ohm resistor to a D882P NPN transistor, which switches the negative side and turns on the LEDs. So there you go.